Pokereum.
Okay, Jay Slay, so this is one in a series of videos that we're going to be doing, exposing the Pokereum general architecture and GUI, which is what we're starting with today.
Oh, great, because
Yeah.
I was putting together some material for SuperDAO, and you wanted to get like a general sense of the UI and how the back end works for Pokereum. So this is perfect timing.
All right, great. So let me just fire up the client here. We use an Electron shell, which is basically a cross-platform development tool to be able to deploy apps across desktops. In this case, is a Poker app, right? Let me switch screens here. The client is fired up, and I'm going back to the screen. Pokereum, there we go. Start screen share, and there we go. Can you see my screen?
Oh yeah, man, looks good.
Thank you. It's a restored version after I lost a whole bunch of files. You know, my computer was hacked, and we restored it.
Oh
And it
wow.
was painstaking work, but it's back now.
Yeah, I love the lobby floor. Looks very realistic.
Yeah, right. That's one of the intentions. We're trying to trying to immerse the player experience, um, get players immersed in the game through the user experience, look and feel, and every type of heuristic we can get in there to, enable the player to endure for hours
So
and hours. We're trying to
okay.
get you addicted.
Okay, cool. So, like, what are some of the actions that players can do?
Well, general actions like you would have in a poker game. You can fold, check. For example, if I sat down, I have a player avatar, which um, on the right hand side you can see how much money, play money, I would say, and then you can bet some money. For instance, you can call, you, you can raise, or you can just go all in, right?
Nice.
You can also chat, but this is front end only for now. That's how the chat works over there. And if
Okay.
I had another player on the other end of the world or opposite me, you would see their responses on the right hand side.
So chats everyone can see.
Yeah, chat. Everybody can see the chat. It's basically routed through the telehash protocol layer, which we're going to be, touching on that briefly. But it enables real time communication between peers in a P2P fashion.
Okay. So what's gonna make this like decentralized?
Yeah, so decentralization comes with our architecture and what we build it, what frameworks we built it upon, what the design is, and what cryptography and mental poker-like schemes we use to achieve peer-to-peer games over a distance. So I'm going to switch screens to kind of give an illustration of what I'm talking about before it becomes all too abstract. Um, so here we go. So I've switched my screen. Here's a basic poker finite state machine. This applies to centralized games or decentralized games. It basically models the state transition um, of what is happening during a game session, right? So we have we have in a poker game round, we have a pre-flop, we have flop, we have the turn and the river, right? Each one of those states, right, represents a state transition, meaning something has changed between each step. At each step, we can all go back to the initial step, which is that the middle representation you see there, which is the initialize, shuffle, and deal cycle, right? And that's just a basic overview of what it means to have finite poker finite state. Next diagram we'll explore how our state transitions work. So we use a framework called telehash to enable each player to send the state, the new state that results from the action they make in a game state. So in this diagram, you can see player 1 sends his states to player 2, player 3, and player 4. And likewise in the flop stage or the turn or the river stage. And not only does, in that scenario that I was discussing before, happen, in this diagram, it also shows that each state as it's being played is being sent to a group of nodes on the network whose job is to kind of observe and validate through challenge response mechanisms if state transitions are valid, right? And there's a later times we're going to get into detail of how all of this is all happening. And so now we get to the general overview of what makes Pokereum decentralized. We have a UX layer, and all I explained previously was to kind of describe, to kind of give a background to be able to understand, this, how our architecture works in general. So at the first layer, we have a UX, and underneath that, we have a telehash real-time communication protocol, which kind of enables game hash calls, folds to be communicated in real time across clients, across the network. After that, we have the geth client, which does a lot of things. It enables us to integrate Whisper, which is also a slower, more redundant P2P communication network. It's a distributed hash table that allows us to send messages and broadcast, games all over redundant games all over the Pokereum network. Obviously, the geth client also connects to the blockchain, and from the blockchain we can anchor important points in the history of the network into decentralized storage, which is going to either be ipfs, which is making lots of grounds right now, or Swarm. Describing it in general, that's what makes it decentralized. P2P interactions with real-time communication technology and blockchain technology that's anchored and stored redundantly into decentralized storage.
So you were describing I think you described, but I'm not sure, how players are going to find each other on the network.
Okay, yeah, that's awesome. That's an awesome question. So if you look at the diagram one more time, I don't know how clearly you can see this, but this is one of our development schematics. In that geth layer, the geth fly client layer, would the Whisper layer is also included, which enables us to broadcast games through this protocol. Essentially, games are broadcast using topics, as defined by the Whisper protocol, and depending on how your game is structured, either for public, searching and engagement or for private consumption for previously known um, players, you can find games on the network. So games are found on the network use by the use of the Swarm, the integrated Whisper protocol in the geth clients, right? And basically the Whisper client provides for redundant DHT network, which is a distributed hash table um, technology, and I believe it uses the Cademia framework.
Okay, so how does the actual dealing of cards work?
Yeah, so this goes back to that problem of mental poker, which everyone has been trying to find a solution to. We got involved, prior to 2012 and came up with a formal solution, partly described in the Pokereum white paper early 2014, even before the Ethereum network was alive. Our solution is called Shadow Poker, and it basically mimics the properties of what it means to play a game of poker, right? We don't actually construct the Fisher Yates shuffling algorithm in a smart contract or client side or anything like that. We mimic the properties of what it means to shuffle and to have a provably distributed number of permutations of cards. And then, with different combinatorics, right, between players with the help of what they can read from the smart contracts, players can by themselves select their own card, right, which can be proven and can jointly select the next card also.
Okay, and also, how do you make sure that a player can't alter um, their move after the fact?
Yeah, so that just has to do with encryption, public private key pair for um, each player's turn in a game session, a game round. Each state change is signed by those key pairs, and uh, it constitutes uh, somewhat of a bond of the stake being used at a table in similar smart contract to a state payment channel. So, you know, uh, it's in the player's best interest not to mess with the order or the history of the progression of the game. I'm just gonna. So we have also um, uh, a simulation
Oh, nice.
of what it means to play a game. Uh, Helps us to determine the bugs in the UI, what the play is going to be like, how to make changes in terms of feel, heuristics, debug what's going on in at every turn. You know, it's a pretty decent um, way to kind of monitor and test uh, the progression and development of the UI aspect of things and how information is sent uh, from client to client.
And so, how do you, kind of mitigate collusion? Having two players that are colluding with each other at the same table.
Um, so collusion can never be eliminated completely. Um, you can drastically, to a high probability, um, reduce it beyond a point of concern, right? So the first aspect we use, and is described in the white paper partly also, um, is by randomizing table access. So in starting the game, you don't know what table you're going to get into. So that's one. That's one way. You know the category and group. That means you know the stake and the minimum stakes in the the stakes that you're going to be the table that you're going to be playing in, but you don't necessarily know what specific table you're going to be joining. Obviously, when we are bootstrapping, that is a weakness that we have to overcome, like any other network. The second way we use to mitigate is to use an decentralized collaborative um, algorithmic filter to give users a choice to select or to warn users of players who might find who play um, together fairly often. If the algorithm finds such an instance or user selecting such a table, it's to give a heads up to the player beforehand if they want to continue to join that table. Now, when you get to a specific game console and you start to play, obviously in a chat box, there's no way to mitigate communication completely between players. But from there on, you can use common sense to a degree, and, to
Yeah, because you see what everybody's chatting about, so it's nothing hidden. You're gonna be able to tell.
yeah. So if I said, hey, anybody wants to private message, you know,
Right,
like
right,
if I
right.
send a message, that's on my own prerogative to get out of there, right? I'm not no longer going to participate in that. But we can go further than that and have filters for email addresses, certain characters. I mean, it could go on. It can. There are multiple heuristics we can use to diminish or improve the experience to fight against collusion. It wouldn't totally extinguish it, but it would just waste the time of a lot of people trying to make this a hobby or attack on the network.
So players can like leave the table um, when they feel. Oh, if they just have to leave.
Yes, yes.
Nice. And so this is going to be supported by um, multiple platforms, right?
Yeah, we're gonna be deploying on the ETH, and ETC networks first, and then after that we're gonna be deploying to the Rootstock network and any other EVM supporting blockchain. So it's meant to be EVM neutral, right? Which means that as long as you can support our DApp, we are going to deploy there. Um, the organization SuperDAO, which supports this DApp itself, is on a blockchain that has a social contract, so that's better um, for the foundation. But our dApps can go anywhere, and um, we can provide for any other up and coming EVM supporting blockchain.
And what are the next phases for Pokereum?
All right, so the next phase is if I switch screen here. Um, um, we have a roadmap. Is to refine the UX, continue to test. Um, and refine the UX. We are talking about the lobby also, which is also in progress, which is also part of the experience. And the next step will be also the revised white paper. There is a, a mock-up of the improvement to the white paper, which is basically Shadow Poker, which is the second half to the white paper, which details how our solution is actually implemented with examples. And so that will be included in the white paper in what is the draft right now. And after that would be the complete UX telehash integration, because the telehash layer is developed but not integrated into the UX right now, because we were having some issues in terms of complete in terms of a demo, for instance. We had to kind of step back from integration and present what we have currently before we proceeded with integration. And after that, it would be the actual Shadow Poker as described by the upgraded white paper integration. And then, the DHT network integration, which is Whisper. And then, we'll be ready for, the alpha launch, which is scheduled for, the first half of next year.
Great. Well, thanks for bringing me up to speed, and the UI looks great. I'm excited. Can't wait to see as further development happens. And thanks a lot, man. I guess we'll talk at a later point.